So the original question for question 4 is again another one of these problems that I had some requests on, is to try and make some problems like this where you have this molecule and what you need to be able to do is to identify the different intermediates along the track. So, you know, a couple things. I think one of the things that you should always do is, if you're having some difficulty, work backwards. You know, that's actually the best way to approach synthetic problems in general, is to really work backwards. So what do we know here? We know that this is going to be derived from some sort of diethyl malonate type of reaction. And so let's look to the last step. So hopefully you've done enough of these now that what this step should scream out to you is decarboxylation. Right. And so you think about what is the parent molecule to this? Well, you're either going to have this or that. Turns out it's the same thing, depending. So so you work back to this step. So that's this molecule. Alright, what is this? Well, what it looks like you're doing here is, if you look at those reaction conditions, all you're doing is cleaving an ester here. So you know the diethyl malonate is going to have esters on it, and then this side chain group here, you would have to use the empirical formula to get at that also having an ethyl ester on it. So this is your part that's derived from diethyl malonate. This is your side chain. So then all you need to do is be able to make this disconnection right here. Hopefully what you can see is that this is a perfect substrate to react with the diethyl malonate nucleophile to undergo conjugate addition.